How to solve the depressed cubic. So we're deep diving now. I'm going back to x here rather than y because we're now doing it for its own sake rather than as part of a general cubic. All right. And just a historical note, like I said, the 16th century Italians only used positive numbers, and so they wrote it like this. And they didn't solve only that, they had to solve a bevy of equations. All right? So if we do x cubed plus ax equals b, they'd then see, well, x cubed equals ax plus b is a different kind of equation. And x cubed minus ax equals b is a different kind of equation. Right? Not to us, of course. Thank goodness for negative numbers. But to them, they would say different equation and it has this solution. Okay, all right. I don't think there's anything obvious you can do to this to make it solvable. So let's do that. We used to have one problem, now we've got two. So we let x equal u plus v. We do the substitution. We expand it. There's our cubic part, there's our linear part, and there's our b. Bit of grouping, so a bit of factorising there, and then we can see there's a common factor here that can, okay, and I've bolded and coloured that to suggest that this is somehow progress. This is apparently going in the right direction. All right. All right. Is there anything obvious you can do to that? Now, thinking creatively, can you think of anything you could do to that to make progress, to solve it? And I will admit that I'm sure I wouldn't have thought of anything. I read a book. Sorry?
Factorising cubes.
Factorising the cubes? Okay, you try that for homework. See how? You are right, of course, because you will get that factor, and so then, yep. Okay, anything else? This is actually very much thinking outside the square.
You got a pun?
Yeah, unintentional. And I hate unintentional puns. I'd rather have thought of it. Okay, so this can be solved if, and I'm not saying if and only if, I'm saying if. What if 3uv plus a were equal to 0? Now that doesn't solve it, but what if this term were equal to 0? What would that then imply?
u cubed plus v cubed equals b.
That's right. Okay? So, working in reverse, if those two things were true, then that would be solved, wouldn't it? Yeah? And so this is how we proceed. We derive these simultaneous equations from that. And I said if, not if and only if. Okay, when I first read this and tried doing the work, I was thinking, okay, right, elegant, I like your choice, well done. But what other options are there to solve this, and would they give different solutions, and how do we know this is heading in the right direction? But that will solve it, and so we can make v the subject there, so v equals negative a over 3u. We can substitute it into there, because they both have to be true, and arrive at this. Okay, so u cubed plus our value for v cubed equals b. Expand that power, and we get that. Now, I'll take that over that any day, right? So it was progress. And this is a much easier question. What can we do with this?
Multiply by u cubed.
Yep. Oh, before we... It's good to get our bearings here. Not too many numbers here to hang our hat on. So A and B are
Constant.
constants from the equation. U and V are variables because x was equal to u plus v. All right? So we want to solve this for u or v. Well, there's no v, so we want to solve it for u. We don't want to solve it for a or b. So solving it for u, well, let's get rid of that fraction and we can make a quadratic. Okay? So if we multiply by the denominator, we get this. This is a quadratic equation in u cubed. Okay? And quadratic equations can be solved. One thing I didn't, I'll keep that for the history later. No, I will mention it now. In 16th century Italy, the full, thorough treatment of quadratic equations had been known for 500 years, 450 years. And the idea of cubic equations had been known for a couple of thousand years. Anything to do with volume, you can make a cubic equation. So, and the solution to quadratic equations had been boiling for a long time. So then people started working on cubics and were quite frustrated that they weren't getting anywhere. So early 16th century, this was a massive breakthrough and using knowledge that had been around for nearly 500 years. Okay, so our coefficients are 1, negative b and that. So we sub them into our quadratic formula. Simplify. I'll just go through it sort of slowly if you want to, quickly check that things are working. Get rid of that big fraction. Put the half inside the square root. And expand, and that's where we leave it for u cubed, right? So we've got u cubed equals half b plus or minus that. And we saw that expression somewhere in one of the summaries before. So two solutions. This often happens, doesn't it? We derive a quadratic equation, we solve it, we have two solutions, and we go, all right, what are we going to choose? Any thoughts? Two solutions. We need one for u and one for v, don't we? All right, we've been working with u, but x equals u plus v. We need something for u and something for v. So it'd be kind of nice if we could just say, let the positive one be u and let the negative one be v. Yeah? Now, in the article, we derive it by saying, well, the relationship between u and v is u cubed plus v cubed equals b. So we can substitute this in and work it out for v. And yes, we do end up with those. But for this presentation, I just want to point out, well, this is where we've come from. X cubed equals ax plus b, x equals u plus v, u cubed plus v cubed equals b, a bit of helpful highlighting. So if we allowed u cubed and v cubed to be the positive and negative case, would that work? Would that be satisfied? Yeah. Yep. That plus that does equal b, doesn't it? Okay, so once again it's an if, not an if and only if we look at it this way, but I like it. Works for me. Okay, so x cubed plus ax plus b has the solution x equals u plus v, where u equals the cube root of what we just had and b equals the cube root of what we just had, and therefore that. Okay, there we go.
What was the condition we put on it again? Remember, you started from if equals 0?
Yeah.
3a. Someone got it?
3uv plus a equals 0.
There you go. 3uv plus a equals 0. Okay, now you wouldn't want to write that too many times, so we can summarise it, right? We're more interested in the structure than the nitty-gritty detail, so that's a much better. And even that feels frustrating that you can't boil that down even further because it's so much similarity there. Okay, so there you go. Some conjugate pairs there, and we get a solution to cubic equation, although like I said, if you worked with different combinations of cube roots, then you probably get the other ones as well. Historical note, they were only interested in positive solutions. If something seemed to be negative, they would have disregarded it as useless, not something we acknowledge. And so they were they knew that every cubic equation would have one real solution, and they were only interested in ones that had a positive solution. They were only interested in one solution. They weren't thinking, maybe we could generate some more. All right, so that's our solution to the depressed cubic.